Hello students. So this session that we are taking is for the topic Newton's identity, which is used in quadratic equations. In the trend of JEE mains and advanced questions, we have seen that a particular set of questions occur very frequently. Okay. So what we'll be doing is we'll be discussing this particular identity called Newton's identity. But before that, what I'll do is we'll first check one question which is based on JEE main, okay, which has been asked in JEE main in 2020. Okay, so let's just check this question. And so this particular question is, let alpha and beta be the roots of x square minus 6x minus 2 equals 0 if an is equal to alpha raised to the power n minus beta raised to the power n for n greater than equals to 1, then the value of a10 minus 2a8 upon 3a9 is. Now this question has been asked in JEE main 2021 25th Feb shift 2. Okay, so what we'll do is we'll first solve this question in general approach. Okay, we'll take the general approach for solving this particular question. Okay, so let's take this quadratic equation here. The quadratic equation is x square minus 6x minus 2 is equal to 0. The roots are given alpha and beta. Okay, now if the roots are alpha and beta, so alpha and beta will satisfy this particular equation. So we can write here alpha square minus 6 alpha minus 2 is equal to 0 and beta square minus 6 beta minus 2 is equal to 0, right? Now what we'll do is we'll write what has been asked in this particular question. So what has been asked is a10 here. Asked is a10 minus 2a8. Okay, let's say we find this value in terms of a9. Let's say we just manipulate this value. Okay, so what is a10? A10 will be, see here, alpha raised to the power 10, right? So this will be alpha raised to the power 10 minus beta raised to the power 10. This is a10 from the definition here, right? Now minus 2 times of a8. Now what is a8? a8 we can write as alpha raised to the power 8 minus beta raised to the power 8, right? Now if we club this particular term and this particular term, will be left with alpha raised to the power 10 minus 2 times of alpha raised to the power 8, this term, right? Minus beta raised to the power 10 plus 2 times of beta raised to the power 8. Now if we take terms common from here, we can see that this becomes what? Alpha raised to the power 8 into alpha square minus 2. This becomes beta raised to the power 8 into beta square minus 2, right? Now see, since this equation satisfies, now we know the value of alpha square minus 2 is 6 alpha from here, right? We can substitute this value from here, right? So this value is what? Alpha raised to the power 8 into, now this will become 6 alpha, right? Is this clear to you? Now here minus beta raised to the power 8 into 6 beta, this will become, right? 6 from here and 6 from here, we can take common out, which will become 6 times. Now this gets multiplied with this one, right? So this will be alpha raised to the power 9 minus beta raised to the power 9, right? Now this expression is what? This is a9, right? So this becomes 6 times a9, right? So the expression that we are getting here is what? See, the expression that we have got here is basically a10 minus, see here, 2 times a8 is equal to what? 6 times a9, right? Now the question is a10 minus 2a8 upon 3a9. So we have to divide the entire expression with 3a9. Now here, if we divide it with 3a9, this becomes a10 minus 2a8 upon 3a9 is equal to what? Is equal to 2. So the answer for this particular question will be 2 here, right? I hope this is clear. Now what we'll do, see, for solving this particular question, we had to do this much of calculations, right? Now what I'll do is I'll introduce the identity which is called Newton's identity, what it means, and how can we apply this particular identity to solve this question, okay, or these sort of questions, okay. So what I'll do is I'll first introduce the identity, okay. So Newton's identity is let's say if a quadratic equation is given, let's say quadratic equation is ax square plus bx plus c equals 0. If this is a quadratic equation, right, and let's say the roots are alpha and beta, right, then then we define, let's say, an expression Sn which is equal to alpha raised to power n plus, let's say, beta raised to power n, where n is a natural number, n greater than equals to 1, right? So this is an expression Sn where Sn is equal to alpha raised to power n plus beta raised to power n is greater than equals to 1, right? If this is the expression like this, then Newton's identity is, okay, Newton's identity is, this says, see here, a times s of n plus 2 plus b times s n plus 1 plus c times s n is equal to 0. This is Newton's identity. What does it mean? That a times, now how do you find Sn? Sn is what? Alpha raised to power n plus beta raised to power n. That is Sn, right? Sn plus 1 would become alpha raised to power n plus 1 plus beta raised to power n plus 1. So whatever is written over here, that gets propagated over here and here, right? So Sn plus 2 would become alpha raised to power n plus 2 plus beta raised to power n plus 2. Understood? Now, if we want to prove this particular identity, what we can do is we can actually use this quadratic equation, okay. We can use this particular quadratic equation. The quadratic equation is ax square plus bx plus c equals 0. Here the roots are alpha and beta, right? So if we have to write, let's say Sn. So what was Sn? Sn was alpha raised to power n plus beta raised to power n, right? If we have to write Sn plus 1, this would be what? Alpha raised to power n plus 1 plus beta raised to power n plus 1. And if we have to write the value of Sn plus 2, this will become alpha raised to power n plus 2 plus beta raised to power n plus 2, right? The identity says that a times s n plus 2 plus b times, right, s n plus 1 plus c times s n is equal to 0. This is the identity, right? Now what we'll do is, so these are the expressions which are given in the identity, and this is the particular identity, right? Now what I'll do is, for, let's say, for proving this thing, what we can do here is let's say the roots are alpha and beta. So alpha and beta will actually satisfy this particular equation. So a alpha square plus b alpha plus c is equal to 0 because alpha is a root, right? Now if we multiply this particular equation with alpha raised to power n, what will it become? Multiplying, let's say, multiplying with alpha raised to power n, we will get a times alpha raised to power n plus 2 plus b times alpha raised to power n plus 1 plus c times alpha raised to power n is equal to 0, right? Similarly, I can write, see what we have done over here is we have solved this particular thing with respect to alpha. Now what if we had taken beta here? Then this expression or similar expression we'll get is a times beta raised to power n plus 2 plus b times beta raised to the power n plus 1 plus c times, here beta raised to the power n is equal to 0, right? Let's say these are two equations, 1 and 2, and we add these two equations over here, right? Let's say we add these two equations over here, okay? So if we add these two, 1 plus 2, what we'll get is a times alpha raised to the power n plus 2 plus beta raised to the power n plus 2 plus b times alpha raised to the power n plus 1 plus beta raised to the power n plus 1 plus c times alpha raised to the power n plus beta raised to the power n is equal to 0, right? Now what is this? This is s of n plus 2 plus, what is this one? S of n plus 1, right? And what is this one? Okay, a times, let me just erase this one, okay? I'll write here a times s n plus 2 plus b times s n plus 1 plus c times s n is equal to 0. So this is basically the Newton's identity which we wanted to prove, right? So this statement is true basically, right? Now what we have to do, let's say, so this statement would be true for n greater than equals to 1. So let's say if we want to derive an expression for S6, S7 and S8, what we'll write is n equals 6, right? So what we'll do is, let's say we'll take the example of previous question which we solved. So in this particular question, they have actually asked here the relation in 8, A8 is what? Alpha raised to the power n minus beta raised to the power n. Now here you can understand that here in Sn, the expression is alpha raised to the power n plus beta raised to the power n, right? If we write alpha raised to the power n and minus beta raised to the power n, then also this expression will be valid. Why this will be valid? Because we'll be, if we subtract 2 from 1, if you do this minus this, then here negative sign will come, here negative sign will come, and here negative sign will come. So basically for alpha raised to the power n minus beta raised to the power n, also this particular expression will be valid, right? So if we apply this particular equation identity in alpha raised to the power n minus beta raised to the power n over here. Here this identity is alpha raised to the power n minus beta raised to the power n. It holds for this one as well if we subtract the equations, right? So if we use this one over here, now you can find the value of n from here. See, the values are 8, A8, A9, A10, right? So if I use this particular identity in this equation, this equation is here, this equation is x square minus 6x minus 2, right, is equal to 0, right? So this identity will become, now I am taking here n is equal to 8, right? And what is the value of a? A is 1, b is how much? B is minus 6 and c is minus 2. So if we use n equals 8, this will become a times s n plus 2, which is s10, right, minus b time minus b. What is the value of b over here? Plus, what is the value of b? B is minus 6. So minus 6 times s9 will come and minus 2 times s8 will come, right? Right? This will be the expression according to Newton's identity. And so the value of C, A10 minus 2A8, right? So this is A is what? A is 1, right? So A is 1 over here. I'll just erase this. So A10 is S10 over here, right? So I can find S10 minus 2S8 is equal to 6Sn. So S10 minus 2S8 by 3S9 is equal to 2. Now here S is basically A, right? Sn is An. I am writing Sn as An over here. So this particular value is 2, which we directly got from Newton's identity. Okay. Now what I'll do is I'll take few more examples which has been asked in JEE main previous year questions, okay, papers. Okay, let's take this particular question over here. Okay, so the question is, if alpha beta are roots of the equation x square plus 5 root 2 x plus 10 equals 0, where alpha is greater than beta and Pn is equal to alpha raised to the power n minus beta raised to the power n for each positive integer n, then the value of this is equal to, right? Okay, this is the question. Now what we'll do is, this has been asked in JEE Main 2021, 25th July, shift 1, okay, paper. Now this value we have to find, right? The expression is P17 P20 plus 5 root 2 P17 P19, okay, upon P18 P19 plus 5 root 2 P18 into P18. Okay, so what I'll do is I'll take common P17 from here, right? P17 has been taken common. What we can see here is P20 plus 5 root 2 times P19. This is the value. Here we can take P18 common from here. If you take P18 common, we'll be left with P19 plus 5 root 2 P18, right? Now, now see, if we apply Newton's identity in this one, what we'll get is A is 1, right? So we'll get Pn plus 2 plus 5 root 2 Pn plus 1 plus Pn is equal to 0, right? Right? In this one, we can put n equals 17, 18, 19, 20, whatever we want, we can put, right? From here, see, if we observe this particular expression here, you can understand that the value of n, which we have to put over here, n plus 2 has to be equal to what? 20. So in first one, n is what? 18, right? So in this one, if we put n equals 18, we'll get P20 plus 5 root 2 P19 is equal to what? Minus of P18, right? And in the second one, here P19 is there plus 5 root 2 P18. So P19 plus 5 root 2 P18 is there, right? So this here n is equal to what? 17, right? So if you put n equals 17, this one would become what? P19 plus 5 root 2 P18 is equal to what? Minus of P17, right? I hope this is clear. Now what I'll do is I'll just substitute the values of these two from here, right? So this expression becomes what? P17 by P18, and this value from here, this value is minus P18, right? Minus P18, and this value is what? Minus P17, right? So minus of P17, and minus minus gets cancelled. This is 18, everything gets cancelled, so we are left with 1. Okay, so the answer of this particular question is 1. Now if you don't know Newton's identity, what you have to do is you have to write the values of P17, P20, 19, 18, everything you have to write. So it will obviously take more than what we have done over here, right? So this particular question might take 3 minutes, 4 minutes of your entire paper, whereas here if you solve it fast, you might be able to solve it in 10 seconds, 20 seconds. Okay, so it will save your time and for sure you'll get the marks. Okay, we'll take one more question. Okay, let's say this particular question we are taking. Okay, so in this question, I'll just read out the question for you. The question is, so this question has been asked in Jan 7, 2020, second shift. So the question is, let alpha and beta be the roots of the equation x square minus x minus 1 is equal to 0, right? If Pk is equal to alpha raised to the power k plus beta raised to the power k, where k is greater than equals to 1, then which one of the following statements is not true? Now we have to find which one is false over here out of the 4. So basically you have understood that we have to apply Newton's identity over here. Now if we apply Newton's identity here, the identity will become what? P of, I'll write over here, P of n plus 2 now minus P n plus 1 minus Pn is equal to what? Is equal to 0. This will be the result, right? Newton's identity statement, this. Now if you put n is equal to what? Let's say if you put n is equal to 1, this will become, what will this become? P3 minus P2 minus P1 is equal to 0, right? Now if you put n is equal to 2, you'll get P4 minus P3 minus P2 is equal to 0. Let's say we put n equals 3, we'll get P5 minus P4 minus P3 is equal to 0. See here in the options, if you check, we have P3, P5, P4, then we have P5, from here P1 to P5, and here P5 is written, right? So basically we have to manipulate till P5 and equals 1, 2 and 3, right? Now if I ask you what is the value of P1, right? If I ask you what is the value of P1, so here P1 is defined as alpha raised to the power 1 plus beta raised to the power 1, which is what? Alpha plus beta. Sum of the roots is minus of b by a. From here you can say this value is 1, right? From this quadratic equation. What is the quadratic equation? X square, here x square minus x minus 1 is equal to 0. The roots are alpha and beta, right? From here we can say alpha plus beta is minus b by a, which is 1, and alpha beta is minus 1 over here, right? Now if I ask you, tell me the value of P2 over here, how would you find P2? P2 is what? Alpha square plus beta square, which is how much? Alpha plus beta whole square minus 2 alpha beta. Now we know the value of these two, right? What is alpha plus beta? It's 1, right? So whole square is 1 square minus 2 times alpha beta is how much? Minus 1. So 1 plus 2, which is equal to 3. So here we have the value of P2 as 3, right? P2 is 3, right? So now we can substitute the values of P1 and P2 in which equation? In this, let's say I call it the equation 1, I call it equation 2, and I call it equation 3, right? So here if I substitute the values of P1 and P2 in equation 1, what we'll get is P3 is equal to what? P1 plus P2. What is the value of P1? P1 is 1. What is the value of P2? P2 is 3. So we have the value of P3 as 4, right? Similarly, if I ask you what is the value of P4, how would you find the value of P4? P4 we can find from here, right? P4 would be equal to how much? P3 plus P2, right? We know the value of P3, we know the value of P2 as well. P3 is how much? 4, and P2 is how much? P2 is 3. So 4 plus 3, 7. Similarly, we can find the value of P5 as well, right? P5 would be how much? P4 plus P3, right? What is the value of P4 from here? P4 is 7. And what is the value of P3? P3 is 4, which is 11, right? Now we have the values of P1, P2, P3, P4 and P5, right? Now we can check the options. First option is P3 is equal to P5 minus P4. What is the value of P3? P3 here is 4, right? So 4 is equal to, what is the value of P5? P5 is 11. So 11 minus, what is the value of P4? P4 is 7. Does this satisfy? This satisfies. So this particular A option is correct over here, right? We have to find incorrect option. So A option is correct. Second option is P5 is equal to 11. P5 is 11 only. So second option is also correct. We have to find the incorrect option. Now third option is P1 plus P2 plus P3 plus P4 plus P5. We have to find the sum of all these. Now we can find what is the value of P1. P1 is 1 plus P2 is how much? P2 is 3. Now P3 is 4 over here, right? So 4 and P4 is 7 and plus 11. So we can find the sum. This is 18, 22 and plus 4. This is 26. So this option is also correct. Now what is the value of P5? P5 is 11 is equal to P2 is how much? P2 is 3 into P3. Now what is the value of P3 is 4. So this option is wrong, right? So out of all these 4 options, option D is wrong. So the answer for this particular question would be option D. Okay. I hope this is clear to you. Okay. Thank you.